and you can see we're picking up stars there. So let's go ahead and get started. As I shared with you, if you saw the email or the description, what we want to try to do is go to some of the lesser known targets. So let's look at our targeting software, and we're kind of functioning on some new territory here tonight. This is a new laptop, and I'm hoping that that will be a good thing. Let's do a sort on visibility and altitude. And let's look up here at the top and see what we've got. Why don't we start with something like this Spindle Galaxy here. Now you can see we're already connected to the mount. So I'm hoping that when we tell the mount to slew to the object, and we'll have you look there at the scope, and we're hoping that uh, that's the scope that you see in the lower right-hand corner there. It's an 8-inch RASA, and it has a ZWO ASI 2600 MC Pro astronomy-specific cooled camera there. Yeah, looks like the scope did okay. Now up here in the upper left, there is a picture of the sky, but it is pretty dark, isn't it? I wonder if I can improve that by going to properties, and let's dial up the brightness and dial up the gain of that sky a little bit, so at least you can see something there. Yeah, that's a little better. At least you can begin to see the outline. This little circle you see in the lower part, that's actually the telescope. So you're riding on top of the scope when you look there at the sky. So now let's go see back to Astroplanner for a second. This is NGC 3115. NGC 3115. So let's put our target name up in here, NGC 3115. And then let's connect SharpCap to the scope. And let's use, if we can, plate solving, so that what we'll do is we'll let SharpCap connect with our plate solver to take a picture of the sky. And typically on the first match with the taking a picture with its library of the sky, typically there's an adjustment to be made because, you know, we don't do any kind of star alignment. So this is completely a sort of a blind jump the first time, but that's how close it is. It was within 6 degrees just by doing a blind jump, and now we've plate solved and nudged to line up with the frame, and we're just going to let the scope settle just a little bit so that we can make sure that everything's settled. Okay, I think it is. Now let's start live stacking here. And what live stacking does is it begins to try to collect one image after another. And the images we're collecting are so far 20 seconds at 200 gain. And by collecting those images one on top of another, it is able to combine the brightness of the bright parts and also drop out the noise of the noisy parts. By noise, we mean all the modeling, all the confetti-like interference. And then eventually what we can do here is do a reset of the color balance, maybe based on the peaks, and get those all aligned. And we can take our black levels and put them right around that peak somewhere. And then we can take our mids and pull them in a little tighter. And, the whites probably are okay where they are. The trick with the white is you just don't want the whites, clipping off here to the side. So while that's collecting a few frames, I'll just say that we're really thankful that you're here with us tonight. And again, I'll apologize in case you weren't here right at the beginning. We couldn't get internet, and it was actually quite a chore. So we ended up at the end of the day functioning off of our vehicle internet here. We've got a vehicle hotspot, and we're actually streaming from the vehicle hotspot. So I see Robert, you're on with us, and I know you're over in London. I think, Robert, if I remember right, you're actually working tonight at one of the, uh, I think, one of the Palace service centers to guide the traffic that's going on in relation to the funeral services that are happening. So it's really amazing that you're able to stop in and be with us all the way up from over in London in the middle of the night. I guess there might be 4 or 5 hours difference there, so I wouldn't be a bit surprised what it's not 3:30 in the morning there for you, and that means a lot, Robert, that you would check in um, and be with us. So what we're doing is we're live stacking here, and what we'll do next is it looks like our live stacking is going okay. So I'm just going to unpin this for a second, and let's actually zoom in some. And you can see there's the Spindle Galaxy there in the middle. Let's stick it in a little bit more. Make sure we stay centered there. This Spindle Galaxy is one of the lesser known targets. It doesn't even have a Messier catalog number. NGC 3115 is what it's typically known by, the New General Catalog 3115. And I just wanted to give you like a little audio tour of it here from our folks at Sky Safari. So we're going to play that and see if you can hear that. Let me know if you can hear this audio. Okay, I don't know if you were actually hearing that much, huh? Let's take a look. I'm going to look here in our broadcast software real quick and see what the problem was. Let's see. It says you're supposed to have desktop audio, but obviously you didn't for some reason. So what I think I'm going to do is go ahead and add that here. I'm going to say audio input capture, and I'm going to create a new one and call it narration or something like that. And then for the device, we're going to use, doesn't even list it on this computer. So this is one of the things about using a new computer that we hadn't ever used before. Hmm. Well, I don't know how we can get that desktop. Let me try one more way here. Let me see if there's another way. Audio output capture. Let's try that. Uh-huh. Default. Here we go. Speakers, Realtek audio. Let's try that. Put that in there. And now let me try to play that narration again. I wonder where I can get rid of that desktop audio. Maybe if I go like this and say, no, it's not going to let me there. I'll tell you what, I'll just mute it. And then now we're going to try this new. So here we go. Let's see if we can run that again.
NGC 3115 is a so-called Spindle Galaxy and one of the brightest external systems. It can be seen in a 70mm telescope as a line that is fat in the middle and gives a hint of the look of a galaxy seen edge-on. Larger telescopes show much the same, only the image scale may be made larger with higher power. This is a very bright galaxy and will not fade under too much magnification. One caution, NGC 3115 is hard to locate as it rests in the little-noticed constellation Sextans. It is about 20 degrees south of Regulus and about 8 degrees south of Alpha Sextans.
Okay, I'm hoping that audio came in. If one of you heard that audio there, Robert says he can hear it now. So that's one of the problems with a new laptop. Breaking in a new, like when you take a new boat out on the ocean or something. We're breaking in a new laptop here. So now we've got our narration working, and you can see that the Spindle Galaxy, uh, it is about 31 million light years away. Um, there are actually two different objects known as the Spindle Galaxy. Now, this kind of galaxy, as you probably heard, is typically known as a lenticular galaxy, and they use that word. I've noticed that when there's no real spiral grand structure. Uh, this was discovered by William Herschel back in 1787, and it's pretty edge on. So it looks pretty narrow, like a kind of like a well, like a spindle. If you've ever seen a spindle for a weaving machine or whatever you call that, the spindle is kind of like a knitting needle, and that really does seem like an appropriate name. By the way, this was the fourth galaxy ever where they actually found a black hole, and this was at the time. It was in 1992, the largest black hole known at the time. 2 billion. That's billion with a B, like Bravo. 2 billion times the size of the sun. So it's a huge, huge black hole there. Let's go over and take a look back at Sharp Gap again. And going to just pull in a live stack. We have lost some images, haven't we, of the actual galaxy. So we're not picking up all the images, but at least you can see enough of it there that let's zero in a little bit more, that it does indeed look like a spindle, and that you can tell it's like looking at a spiral galaxy edge on, except there are no spiral arms. So pretty good view of the Spindle Galaxy there. I think we'll save that, and I think I'll just capture a real quick image of it for the little thumbnail sketch too, in the targeting software, and we'll just call it. Is it 3115? Is that what it's called? NGC 3115. Yeah, NGC 3115, and this is the 15th. Wow, this is like tax night in the old days, but I guess everybody got a break and didn't have to do their taxes. So now let's come back over here to our targeting software, and let's do an observation of that. Let's just say we were dropping frames, but we could clearly see the spindle shape edge on. And let's go to our attachments here and add that. See, NGC 31, NGC 3115. It's a nice image for a short bunch of frames. Uh, Now let's go back here and let's also add it as a a user image here. I still haven't made up my mind which way I like it better. Um, and this is as seen on 4/15/2021. There you go, Spindle Galaxy. All right, we're going to have to figure out why that was dropping frames. It could not align. We'll have to figure out why that was happening. I think what we'll do is we'll, back here in SharpCap now, we'll stop the live stack. And tell you what I think we'll do just quickly. We'll go look and see. Tracking's on. Everything looks okay with the mount. I think what we'll do is we'll let's try to send the mount home for a second and just make sure that it's functioning okay. I'm gonna go check those cables on the mount. Sometimes, our cables have been getting stuck, but that doesn't appear to be happening tonight. We appear to have still good good cable management. So that's not the problem. Well, I'm not sure really why it was dropping frames. We'll have to sort that out. Robert, that was perceptive of you to catch that. All right, let's go back to our targeting software here. And I'm curious about this one called the CBS Eye. Let's do our sort again and make sure, see what altitude that is. CBS Eye. I'm going to pull this column over here in our targeting software so we can see what the height is. Altitude, 30 degrees. With any luck, that's the right part of the sky. Let's go check that out. Slew to object. Huh. Not much slewing there, was there? Hmm. Well, that's no fun, is it? Let's disconnect this. And looks like the mount is functioning okay. Let's connect that again and say abort this slew. Oh, there it goes. Not sure what button I hadn't thrown correctly, but it does appear to be slewing now. The mount is a Skywatcher EQR6 Pro. That's fairly low. Let me look with you for a second at the sky view. Yeah, it looks like that should still be sky, shouldn't it? Okay, so this is NGC 3242. 3242. So let's go back over to SharpCap. NGC 3242. And let's make sure we get this aligned properly. Oh, Wayne, it's good to have you here, Wayne. It says the link we posted was no good. Well, that's sad. He went to our page and looked up
Syncing to
another posting.
coordinates.
Huh.
Slewing complete.
So this didn't take you to the Emerald Hills channel, huh? On YouTube. Well, I'm sorry about that, Wayne. I'm glad you found us somehow. We do have 7 people viewing, and we're happy that you 7 are here in the middle of the night like this. We had to start late for a couple of reasons tonight. One reason was, it's just getting darker later. And a second reason is because tonight the cloud base was slow to work out its way out of Louisville. We're going to clear this live stack and let that start stacking. And let's do a reset of this as well, the display histogram. So the clouds didn't clear out by weather advanced meteorological predictions. The clouds were not going to clear out till something like 11 o'clock. And boy, sure enough, at 10:30ish, they began to disappear. And so we were right on the money with really thankful. We had good weather prediction with our weather app. The weather app that we're using now is one that you can go to and try if you want. It's called Clear Outside. Clear Outside. I think maybe Frank was the one who told us about this. Robert, you're familiar with Frank. Frank's up there in Schenectady, New York. And I think he was the one who actually told us about Clear Outside. Wayne, glad you found us anyway. And sorry about that link. I'll have to look up and see what we did wrong in that. Okay, so what we're going to do next here is do a little color balancing and then pull our black levels over here to try to tune up the sky so it looks kind of the way it would look in real life. I'm going to make sure our whites aren't clipping, and they're not. And then our mids actually look okay. We have 4 frames that are stacked and none that are being ignored this time. So let's watch that a little bit more closely this time. And let's go ahead and zoom in a little bit and see what this CBS Eye is. What do you suppose that is? Do you think that's a planetary nebula, perhaps? Let's look this up. NGC 3242. NGC 3242. Let's do the audio tour on this. Here goes.
NGC 3242 is a well-known ghost of Jupiter planetary nebula. This object sits alone in a rather blank area of Hydra. The nebula is about the size of Jupiter in a small telescope, and thus its name. It's much fainter, like a ghost of the planet, and this is how 3242 and planetary nebula in general come to garner their title. In the small telescope, the object appears pale blue, but at higher powers and at least 200 millimeters of aperture, it can be seen the nebula is elongated with odd handles on each side. These objects are caused by a central star leaking its outer regions into space. The star creating all the fuss is a very hot dwarf, but, as is often the case, it requires a large telescope and high power to see the star packed away inside its gas cloud.
I don't know if we're going to see the star inside or not. For one thing, we're probably overblowing it just a little bit, aren't we? I wonder if we were to maybe drop our gain down to 100. I wonder if we could coax a little more. Let's also do another color balance. Yeah, see how we're starting to coax a little more color out of that. Then another thing we can do is back off of these mids, but I don't think that'll help us see the star in the middle. We have blown out the exposure so much. See what we can do here. Now we're at 100% zoom. You can see if we go back to the full frame, that's how tiny this object is. It's just like a star point. But at 100%, it's at least becoming a disk, like a planetary nebula should. You probably heard on that description, planetary nebulae are deep space objects that are kind of blowing off an outer level of gas. Typically, that shell from the outer layer of gas is like a layer of um, fuel that the star is blowing off, like discarding that gas and that fuel. And it doesn't mean the star is dying, it doesn't mean it's a supernova, but it is going through a stage of life. And what we might do to help us see this a little more clearly is look at this in our planetarium software. And we'll use an image here um, that has been captured by the NOAO from the National Science Foundation. This is from the NOAA Observatory. I don't know what that is, but you can see that star inside of there in this image. It's a lot longer and a lot more intense than what we can create just in a EAA view. EAA, of course, stands for uh, electronically assisted astronomy. And um, typically, the views that we go for are, you know, 5 minutes long or 6 minutes long, and then we run to another object in EAA. But this is an astrophotography image that guy named Adam Block has collected at an observatory, and it's hard telling. This might be 5 hours worth of imaging in order to get this view, but it does give us a look at what that inner star looks like as it casts off those layers, and of course becomes a lot uh, less powerful on the inside of the star. But this is all we're going to be able to see tonight. I don't know that we'll be able to get any more out of that than what we can. Look, you can start though to see we have 21 frames, 7 minutes worth of data, and look how we're picking up a lot more of the green now than we were before. Let's go ahead and coax these mids in. No, see that just blows out the middle of that nebula. Let's go the other direction and not blow it out as much. Yeah, now you see you can start to see that white look on the inside. Now what I'm going to do is go beyond our camera's abilities. Yeah, unfortunately, that's what you get when you go beyond the camera's abilities. You start seeing the mosaic pattern. But if you look very closely there, I know it's going to be tiny on your screen because it's a tiny object in the sky. But look at that very closely, and you can see that inner layer, and then also barely you can start to see the beginnings of the actual object. So it's actually not a bad result for EAA. It reminds me of the dumbbell Eskimo Nebula, right? Or I don't know, Robert, if you've ever seen, what's it called? The Emerald, what is that? Emerald something eye. And then there's another one, cat's eye or something. These planetary nebulae typically do have that emerald look. Oh, Cleopatra's eye. That's the one I was trying to think of. But you're right, it does also look like the dumbbell or the Eskimo, especially the Eskimo Nebula. You're right, it does look like that. Okay, we're gonna call it a day at 8 minutes, and we're gonna save a copy of this, and then we'll also do our thing. Now, I don't think you guys can ever see this when we collect our thumbnail image. I don't think it lets you see what we're doing back in the background here, but it's kind of like we go backstage for a minute and we collect this, what was it, NGC 3242. Now these objects that we're trying to do, and this was on 21, oh, let's see, 2021, to get this straight, 0415. These images that we're doing here, you notice we did that Messier Marathon. In fact, Robert, who's on from London tonight, was a part of that Messier Marathon. After we did that Messier Marathon, then now remember that's also called the CBS Eye, and I think I can understand why because it does kind of have that oblong shape, doesn't it? So we're going to say here we can see why they call it the CBS Eye because it is somewhat oblong in its inner core. Um, and then we'll grab this NGC. Oh, what was it? Now I've forgotten. NGC, was it 3242 maybe? NGC 3242. Yeah, there you go. That's a neat little image there, isn't it? And then back out here, we'll also add it as a user image here. And again, I don't think you see when I file picking, but you do see, I think you will see this as seen on, is this the 16th now? Oh, it's because it's after midnight. That's right. Yeah, so you can see in this little user image, it does look like the CBS logo. What's CBS's old little tag song that they would play? Was it Bum 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 or is that NBC? Who knows what CBS is? Anyway, um, that wraps up the CBS Eye NGC 3242. We'll stop live stacking. Boy, that came out well at the end. That is not bad at all. All right, let's go back to our targeting software. Do a fresh sort so we see exactly what's up. We already saw. Do you see here under images? This U, I think that stands for user image. And the D, I think that might stand for deep sky survey, maybe. But when you see a user image, that means we've observed it there. See how this says PNEB? Are you guys looking at this? See how this says PNEB? That stands for Planetary Nebula. All right, let's go back and pick up the Antennae Galaxy. What would that look like? Oh my goodness, how interesting that is. Let's see if we can find this. Slew to object. Looks like the scope is slewing. Okay, that's okay. And then let's go back over. This is the NGC 4038. NGC 4038. And let's make sure we're on that. You know, this plate solving fascinates me. Oh, that is NBC. You're right, Wayne. I can't remember what CBS sounds like. This plate solving fascinates me. This is a library of plates that the software looks at in like one of its hands, and then also it looks at your camera image in another one of its hands, and it tries to compare the two. And if it can find a match, then what it does is it tries to line up your view with the view of the sky. And if it's
Syncing to
successful,
coordinates.
look, we were within
Slewing complete.
0.04 degrees. So that's not 4/10 of a degree. That's within 4/100ths of a degree of being on target. So again, I really love the Skywatcher EQR6 Pro mounts. The fact that it can be 4/100ths of a degree accurate is just, to me, it's just like magic that it could be that precise. So now that our mount has had a little bit more time to settle, yeah, Now the next thing we'll do then is we'll start this live stacking again. And once again, let's clarify that by live stacking, it means that we're taking 20-second exposures at 100 gain right now. And we're stacking those exposures one on top the next. And as it stacks, the bright spots get brighter. So in other words, your star points and your deep space objects like galaxies and nebulae, those get brighter. And then the random spots in your image, let's say, for instance, it might have been a little bit of noise, those don't get brighter. And in fact, the software is smart enough that it tries to kind of drop them out after a while. Let's do a color balance here. Wasn't very super successful. It's having a hard time with the reds in this image. This is supposed to be the Antennae Galaxy, NGC 4038. Let's go ahead and crank up our mid some. And while we're waiting for that to show up, NGC 4038, let's go over and see if we can find anything about that in our planetarium software. NGC 4038. NGC 4038. Yeah, here's this audio tour there.
NGC 4038 is one of the most enigmatic objects in the sky. Called the Ringtail Galaxy, it appears to be not one but two galaxies joined like Siamese twins and caught in the act of a very slow yet relentless collision. Detailed photos show two bright galaxies, elliptical in shape, sharing one end of their ellipses with the other. Rather large telescopes are needed to perceive this form, but in a 200mm reflector, the outlines of two shadowy players can be seen or imagined. The two objects are amongst the brightest of a long list of interacting galaxies. Most others are beyond the range of backyard telescopes. The Ring-tailed Galaxy is located in the constellation of Corvus, the Crow.
I love it when they say that you can't see this in backyard telescopes. Because look, we're seeing it. and there are two reasons why. Okay, Robert, we'll do that. We'll go back to 200 gain. Good idea. There are two reasons why we're seeing this. First, because we do have a fast telescope, thankfully. It's a RASA 8-inch, and it's known for being particularly fast. And by fast, we mean the focal ratio, light collecting power, you could say, is pretty high. It's a f2. So if you're a photographer, you know what that means. If somebody gives you a telephoto lens and it has a f11, you go inside to shoot a wedding, man, it can't do it because it's too dark in there with that f11 lens. So what you do is you take the f11 lens off and you put on an f5.6 or an f4 or an f2.8, or if you're really lucky, an f1.8, for example. Well, this telescope is an f2 lens, so to speak. Even though it's a telescope, it's an f2 lens. So that means it collects light really fast. So that's one reason why we're seeing stuff that a backyard telescope oftentimes wouldn't be able to pick up on. But another reason why we are able to see this stuff is because we're not looking at it through an eyepiece. And if you were to be looking at this through glass, I'm not sure. Like the guy said, in a backyard kind of scope, I don't know if we'd be able to see anything. But because we're using stacked frames from a very sensitive astro-specific camera, we are getting a vantage point that you wouldn't normally get. And that vantage point is the vantage point of EAA. It's one of the advantages of EAA. On a Bortle 6 sky, what that means is it's pretty light polluted here on the outskirts of Louisville, Kentucky. We didn't drive out to a dark sky site. We're just here on the outskirts of a city of a million people or more. And yet, look at what we can pull in, this amazing pair of galaxies that are doing this ballet. They're starting to kind of collide with each other and drawing stuff out of each other's inner parts. It's basically the tidal effect of one galaxy passing another. And that tidal effect is kind of the way the moon pulls on our ocean and begins making those waves. So when these two galaxies pass by in the night, they're starting to pull on each other and cause each other to be out of whack. So it really is a cool thing to be able to look at this in what you might call a backyard scope. Although it's maybe a decent size, it's still a backyard scope. But it's because we're doing this on a camera and we're live stacking. Look, we have 18 frames across a time span of 6 minutes. And we would be looking through a lens one at a time. I did move from the normal location to miss the building, Robert. I'm about 20 feet and I'm trying to get the habit of being in this new location so we'll be able to see whatever that was. Was it M10 in the Messier Marathon? So, so you're right. You got my number. I did move about 20 feet away, so we'll be out of the way of that building. Robert, you're funny that you remembered that. Well, this is as much as we're going to be able to coax out of this, I think, in a 6 minutes of, I'm sorry, 7 minutes of integration, you might call it, integrating the light. I don't know how much mid-level to get this. If you give it more mid, then you start picking up some of the colors here, and you can see there are some cool colors in this material that's starting to be exchanged. But if you back off the mids a little bit, then you see a little bit more of the dark sky, and that makes the galaxy stand out a little bit more too. So it's just whatever you want to emphasize. It is more art than it is science in terms of moving these. Yeah, M30. You're right, Robert. We're in our M30 position. We're in our official M30 position. All right, while that's collecting just a couple of more frames, let's go over and look at a Hubble image of this. This is from the Hubble Space Telescope, and this is the core of this NGC 4038 interacting with NGC 4039. Isn't that an amazing shot? Of course, that's being taken from a, what is it, $50 billion, I forget what we spent on Hubble, $50 billion maybe, telescope that is out there in orbit. So it doesn't even have to look through air, doesn't even have to look through our outer coat of oxygen and all the atmosphere we have. It's seeing straight through space. But isn't that a beautiful image of the Antennae Galaxies? I don't know why they call it antennae. I guess, is this supposed to look like an antennae of some kind? Oh, I know. It's like antennae of an insect, maybe. Looks to me like antlers or something. Or it's also called the Ringtail Galaxies. And look at all these other names. NGC 4038, Caldwell 60, and all these catalogs. I don't even know what all those catalogs are. But it's a spiral galaxy in Corvus. It's 80 million light years away. Well, that's just fun. Okay, let's go back to SharpCap and do our save. And we'll also capture our little screen grab. And when we do our screen grab, it gives us a chance to crop it pretty close. Boy, there's a lot of material being thrown around in this pair of galaxies. Um, NGC was at 4038 and 4039. So I think I'll just go ahead and label it both. And so now let's go back over to this targeting software also acts as our logging software, as you can see, where we make our notes. So what can we say about our observation here? We liked when we zoomed in, seeing all the material being pulled apart from the tidal forces, something like that. And I don't know if you can see this when we add this attachment. I think when we go get this file name, I don't think that shows up, but I think you can see that now. Let me just look and see if I can tell in. Yeah, you're able to see that. So it does, although it's somewhat diffuse, it does give you a pretty good close-up view of the shape of the object. And then we'll go ahead and we'll add the user image of NGC 4038. And we'll put here as seen 4/16/2021. And so you can see out here in the user image box, it does show you a pretty good image. Robert's wondering if we used a Batonov mask for focus or if we're using the Sharp Cap focus aid. I am so glad you asked that question, Robert, because honestly, I think we should show you what we're using. Let's just take a moment and do that. First of all, I want to go to yeah. So what we're going to do is we're going to open up Nina. And I think, see in SharpCap, I want to disconnect from the camera. And then I want you guys to be able to see with me Nina. And let me make this as big as it can get for you guys. And Nina will connect to the camera. And then we'll also connect to our focuser. And this is a Celestron focus motor, so to speak. So we do this in the equipment, and then here under imaging, look at this. We start our autofocus, and take a look at this. Let me make sure you guys are seeing this, because this is really fun to see this operate. Yeah, you're watching this too. So what does it do? NINA stands for Nighttime Imaging and Astronomy, and it has a routine here. And what it does, look down here at the bottom, in the very lower left-hand side. See where it says it moves the focuser to a certain position, a focus step position. Then it starts snapping pictures. And these are 6-second images. It debayers them, which is another way of saying it figures out the color matching, because the camera has a lot of different little cells, and it takes all those cells and sorts all the colors out so that it makes the image as sharp as it can. And after it passes them through this debayer imaging filter, it stretches the image to the right stretch, and then it stores that image. And it takes several images in a row, and it stacks and compares them. And then it measures the size of the star points in the part of the sky wherever you're pointing. And the neat part about this is you don't have to go to a bright star. You don't even have to open up the truck door. I'm sitting in the back of a Ford Expedition, and the laptop is resting on the console. So basically, I usually lean forward to work on it, and then right now I'm leaning back in the seat and I'm watching this thing at work. You don't even have to walk out there and put the Batonov mask on the end of the telescope, which the Batonov mask is a little screen kind of thing that goes on the end of the optical tube assembly. It creates a sort of a star point pattern if you're looking at a bright star, and using the tools that you can use with astronomy, you can sort out so that those star points align and are perfectly lined up. But what I was finding, I noticed this during the Messier Marathon, especially. It's when I first noticed it. I guess because I was trying to get the focus a little more fine-tuned. What I was finding was, with this fast telescope comes a smaller depth of field. And you guys know that with your photography lenses. If you're a 35 millimeter, um, Robert says, I hope you remember the original focus position. Oh, I have faith in Nina. Um, but I did make notes. I've made several notes about where those focus positions are. If you've used a 35 millimeter camera with lenses that swap out, then you're accustomed to this. You know that each lens has a different focal ratio. And the lenses that are like an f10 or an f11 lens, those typically are they're like not as fast when it comes to collecting light. But with that, you get a little bit of a gain. And the gain is the depth of field is so much wider that your focus can be off a little bit and it still looks sharp as a tack in the picture, because the range of points in the subjects, uh, the range of things that are in focus is more tolerable for what you might think of with your eye as being the right focus. You see what I mean? I mean, what is right focus? How do our eyes decide? Well, how do our eyes even decide when something is in focus? See, that's what I got interested in. I read a lot about this. Um, I started, doing research on it, and one of the things that I found is that the human brain, connected to these amazing eyes that we have, automatically keeps track of what size points of light are. And the wider the point of light is, the brain perceives it to be less in focus. So the definition of focus to the brain is star points are very tiny. And if they get bigger, they're not quite in focus, you see. So what did Nina do? Nina invented a routine. The programmers of Nina, bless their souls, bless their hearts. May God, cause their children to rise up and cause them blessed. They they programmed a routine that takes a series of exposures at a series of focal positions on either side of where you were. And it measures those star points, and then it creates a trend line of those measurements. And the trend line that you're seeing here is the best exposures it could manage at each of these different focal step points um, in the auto-focusing world of this particular motorized focuser for the telescope. So while we've been discussing this, um, for example, the scope moved the step motor all the way out here to a range at, like, say 99.95, and then it moved it back here to like 99.75, and then it moved it here to 99.70, and then it moved it here to 99.55, and then it moved it here to 99.50, and back here to 99.35. And at each one of these dots, it took measurements of the width of the star points. And the great thing about what Nina did is it did it with multiple star points, not just one. Now it's finished. It's finished this little routine, and look at this trend line it created. It said, okay, the stars that I see in this image were smaller at this point right here. And each one of these stands for 5 focus stop positions: 9920, 9925, 9930, 9935, 9940. So look, it said the smallest star points are at 9926. So that's what I'm going to set the focus at, is 9926. So let's go back to our equipment panel and disconnect the focuser and disconnect the camera. Now let's go back to SharpCap and let's connect the camera again. And again, it's doing 20 seconds at 200 gain. But if we look down here, the focuser, well, I don't have the focuser turned on here, and that's because I don't want them to fight each other. The night of the Messier Marathon, I think they were also fighting each other some. What we hope is that these stars, now this is zoomed in at 100%, and I think those are pretty good. These are pretty fine pointed stars, you see. If we go back to auto here, those are incredibly sharp as a tack if we're zoomed out to our full length lens. And if we get in at our 75, these are pretty sharp points. So I think Nina's doing a pretty good job, and I tell you what, I think it's doing a better job than I can do visually with a Batinov mask. That's what I think. So I'm glad you asked, Robert, about that question, because I'm really enjoying using Nina. It's taking my visual guesswork out of it, and it's making it into a scientific study. So I like that. Now, there is some atmospheric disturbance, of course, so it's never going to be exactly right. Well, let's pick up a couple of these galaxies that don't even have names and see what they look like. Here's a Caldwell 40 that's called NGC 3626. So let's slew to this one now. NGC 3626. NGC 3626. How's our scope doing? Pretty good. No complaints from the scope. Okay, we're back to SharpCap. We're going to do a plate solve here and see. By the way, did you notice a while ago? I don't know if you noticed, because I didn't draw attention to it. I kind of snuck you past it, didn't I? There was a point that the plate solver didn't work, and I figured out the reason why it didn't was because I was zoomed in at 100%. And what I learned from that experience is the plate solver
Syncing
is
to
taking
coordinates.
its, look,
Slewing
we're within
complete.
6/100ths of a degree. The plate solver is taking its picture from the zoom that you have the SharpCap camera set on. And I didn't know that before. So you do have to be careful and not be zoomed all the way in from the last object. So I'm learning that. Now you notice there are double star points there because the mount was just getting used to, the mount was still settling in from that last experience. Okay, so we've got our NGC 3626 name in there, and we're starting to collect data at 20-second subframes. Robert, you're very kind for um, for saying that. I also, while this is collecting, I just want to make sure you guys know this is like only my 16th or so time out. I've been out around. Let me get the exact number. I can tell you because in the observation database here, it actually shows me 15, 16. This is my 16th night observing. So stop and think about the things that you've done just 16 times. Let's suppose, you know, when you were learning to ride a bike and you went on your 16th bike ride, or when you were going to driver's ed class and you went out for your 16th driving lesson. I took a driver's ed class when I was a sophomore in high school, or freshman, I think, and it was a full semester. And boy, I tell you, I would not have wanted to ride with me when I was just out for the 16th time driving. I watched the edge of the road and I lined up the little hood ornament with the edge of the road, and that's how I could tell where I was in the road. Well, that's how I feel still in astronomy. I feel like I'm not very good at it yet. In fact, I got to tell you this. The last live stream I posted on YouTube, some gentleman, and I'm using that word liberally, came by and he said something very crass, very like cutthroat. I mean, a person with feelings would have called it unkind. But in my world, I just look at it like he's stating the truth. But I do want to admit to you, I erased his comment because it was mean spirited. And what he was basically saying is, your equipment fails you, and this is. And he used a couple of bad words, and I thought, I'm not even going to leave that in the comment stream. But then I thought about it. Well, the reason he's doing that is because I am not any good at this yet. And that's why I'm so thankful for people like you guys who walk along with me in this. And you're helping me learn and you're walking through this with me. In the old days, astronomy was a very lonely, maybe the loneliest profession ever. Um, Robert's pointing out, well, at least I've got more observation time than what I would have had if I'd lived in northern England, where the weather is 90% likely to be encountering a storm that's making its way from the mainland out to sea or something. I don't know if they move from the sea to the mainland or from the mainland to the sea. Robert, you would probably know that. Um, so what we do in SharpCap is we use this little color balance here and we reset it, and then we do an automatic color balance. But you see, sometimes it doesn't work. That's too red. So there is another kind of color balance we can do from star colors. That's actually better, isn't it, in this case? So this is from peaks in the histogram. This is from star colors. And the star color balance is better for this part of the sky. And I don't know if I look out at the scope, it might be because of the objects, or it might be because of the pollution, the light pollution. Like, to me, that seems a little bit too green, but that's better. Where we just moved it, I think that's better. Now, if we hold our shift key down, we can make finer adjustments. We move our mouse, and it's like the fine tuning on a microscope or something. If we hold the shift key down while we tune, and that lets us get just the blacks. What are we supposed to be looking at here? This is NGC 3626. I'm going to go over to our planetarium program. I'm going to look for this, if it even got it. NGC, what is it? NGC 3626. What is this object? Caldwell 40. Was that right? Yeah. It's a spiral galaxy in the constellation Leo. This is such a random galaxy. There's not even an audio tour of it. Robert's asking where you are, Wayne. And I think, Wayne, do I remember that you're out like in Montana or something? I can't remember where you are, Wayne. It seems to me like you're out in Montana somewhere. She'll come back and tell us. Anyway, NGC 3626 is around a magnitude 11. And it's a part of the Leo 2 group, which is 70 million light years away. But wow, it's so far away, 70 million or so light years, 65 million light years, that it's not going to be very big in our scope. Now, I want to tell you guys, I'm on a journey with EAA, electronically assisted astronomy. I think of this as being on a journey. I'm not taking you guys on a tour. Oh, it's West Virginia. That's right, Wayne. You're up in Chester, aren't you? Chester, West Virginia. Somehow I got it in my head that you had moved from Chester. Anyway, what I want to try to do is get rid of that background color and then crank up these mids until that color comes. And then what let's do is let's start zooming in. And let's see if we can, oh, look, there's that galaxy. NGC 3626, right there it is. Don't you love this? I mean, all of the political wrangling that's going on, and, people are disrespecting each other on social media, and nobody knows for sure if we should move out of Afghanistan, and what should we do to the Russians? And I mean, if you add up all the people at the border and do we wear a mask or do we not? I mean, you add up all that stuff and you get so much unsettling noise in the world. And then you come out here in the middle of the outskirts of a city of 1.5 million people, and you find a reasonably dark place, but that's still Bortle 6, which is still borderline light polluted. And you point a reasonably sized telescope up with a reasonably good camera on it, with some reasonably good software from a guy who's only been out 16 times. And guess what? These galaxies are still there. In other words, the point I'm trying to make is at least the universe has not shifted. the, the objects are still up there in the night sky. Now, Robert's envious of us because, oh, that's where I got, you were in Vegas from 2010 to 2016. That's where I got mixed up then. I thought I remembered you moving, Wayne. Robert's envious of our skies out here, Wayne. But I gotta say, Robert, it's all relative. When we look at our skies, we think they're polluted. And when you look at yours in London, okay, I grant you, yours are way polluted. it's way bigger than our city here. But I love the fact that this galaxy is up there all along. I mean, look at it. It's tiny, but it's tiny because it's 65 million light years away, in part. So we've got 9 minutes of collecting and integrating here. Let's save our picture. And what I was going to say about the fact that I count this as a journey. I don't look at this as a sky tour. capture that a little bit differently. I'm going to take another pass at capturing this. I want to get a little more of those dust lanes. This object has a little bit more dust than what I realized. And this is NGC 3626. This is NGC 3626, 2021, 0416. Let's stop live stacking, go back to our targeting and logging software, and why isn't it letting me? Okay, I'm curious. Why isn't it letting me? Maybe I didn't have this highlighted. It's not letting me make notes. Add user image. NGC 3626. We zoomed so much into that. As seen, zoomed way in on 4/16/2021. You know, that has a little color to it too. Look how it has a little, oh, maybe it's just the way we balanced it. But we didn't do an observation. It wouldn't let us. Why won't it let us? Look, because there's no observation here. Something's haywire. New observation. Okay. We were glad-hearted that in the midst of all of life's uncertainties, NGC 3626 was still up there, waiting to be observed. I just find some kind of, I don't know, that just gives me some kind of hope or something. that, that at the end of the day, somehow, God will work all this out. And I like that. I like that thought that God's got this all worked out. Okay, let's do another sort of our list. Are you guys back on this software with us? Let's do another sort of our list for visibility and altitude. Because I wanted to go down here. Oh, I hope we haven't already missed it. Oh, here's this supernova. That's at 9 degrees. Rats. I was hoping to catch that comet tonight. Why am I not seeing it here on my list? I'm going to do a search for the word comet. There it is. Yeah, it's -10. It rose at, oh, look, it rose at 7:45 a.m. It transited at 3:14, and it set at 11 o'clock. So it had already set before we even started the live stream, because we started late tonight. I apologize. So we didn't get to see this Comet Atlas tonight. That's sad. Sorry about that. We could check and see. I don't know if this supernova, here it is. It's 11 degrees above. Boy, that's probably going to be too close because I do have a ring of trees around me. And we've already observed it. See, look here. We've already uploaded a picture of it before. So we don't have to do that tonight. Let's go ahead and, in fact, let's go ahead and delete that from our, yeah, from our list. All right, let's do one more sort. Oh, I bet it would have, Wayne. You're right. Out there in Las Vegas, it's a great idea. We'll have to travel out there and see where you were someday. And you're right, Robert. I like that chain, but I was trying to sort of stay away from the Messier objects since we did 14 hours on them. About a month ago, we did 14 hours on them. So that's what got me into this idea of a bunch of little known objects. Let's do this. Caldwell, Caldwell 3, NGC 4236. Let's slew to that. So NGC 4236. NGC 4236. 4236. You know, this new laptop is doing us a good job. Oops, I'm zoomed in. That's not going to work, is it? Um, let's try that again.
Syncing to
Oh, we wouldn't be
coordinates.
allowed to go where you work.
Slewing
Must have been someplace
complete.
secure. This new laptop is doing us, I think it's doing us a fine job tonight. It has 48 gig of RAM, and I was accustomed to just 16 gig. Listen to me, just.
Syncing to
Look,
coordinates.
we were eight
Slewing
one hundredths of a
complete.
degree, within 8/100ths degree accurate. It's amazing. This has 48 gig of RAM instead of 16. It also has 11th gen Intel i7 chip, so it's very fast, and it has a new kind of graphics that's been incorporated into the 11th generation Intel i7 chips. So I like the fact that um, we're kind of enjoying that extra headroom of RAM, and I also like the fact that we are enjoying the um, faster processor and also the graphics. I think all that's helping us. But I'll tell you one thing I also like. This laptop has more ports on it. So I don't have to use one of those crazy little dangling adapters that plugs into the side of it. Um, I really like that because that dangling adapter deal was for the birds. Um, it meant that you had loose cables hanging around, and your connections were plugged into an adapter that just dangled from the laptop from a loose cable. So I would try to Velcro them, and I thought about taping them up, somewhere to the laptop or something with, gaffer's tape or something like that. Um, I think you're right, Robert. I think Wayne probably did work in Area 51. But this new laptop, it doesn't require you to plug in that adapter for extra USB inputs. All of the connection that you need, and we have one USB coming from the camera, That's a USB 3 signal. We have another USB coming from the mount. And the USB 3 signal from the camera, we also have the focus motor plugged into it, and we're using it as a hub. Um, and there's something else plugged into that. What else? Besides the focus motor. Oh, I know. We have the camera that rides on top of the scope is plugged into the camera that's coming back at USB 3. So that's quite a bit of bandwidth, you see. It's got that camera signal from the scope and the camera signal for this sharp cap. Um, and then bring those reds down a little bit. That's too much red. And then, in addition, the USB from the mount comes back to the laptop. That's just ugly. I'm shooting with flats here, in case you wondered. Now let's zoom in a little bit and start looking for this galaxy. Oh, right there it is. Look at that. Wow. Look at these stars out here. Do you think they're part of it? Surely not. Do you think maybe there is a bit of a cluster here? Because it looks sort of like we're in a cluster. This is NGC 4236. Tell you what, we're going to go over to our planetarium program. And by the way, look what I did to the planetarium program. I said, show me a lot more galaxies. And it said, okay, I can do that. Then I said, show me a lot more stars. And it said, no problem. I can do that too. NGC 4236. And I don't know if I'll leave it this way, but I kind of like it. NGC 4236. So this is a spiral galaxy, but you notice it does not have the audio. It's a nondescript, oftentimes unobserved galaxy. It's located in Draco, so let's center on it. And boy, that's so many stars that you're not even able to see and get a sense of the constellations. Can you? Because there's so many stars. Let's let's go to our deep sky and back those off a little bit. Because I admit I went a little bit crazy. Let's come back to like 9. And let's go to our stars and bring those back to like 8 or something. Now let's go to settings and make sure that in constellations we show the names. Well, it says they're on. Are you seeing? Oh, it's because we're so zoomed in, maybe. Now let's. Where is Draco? I guess this is Draco. Remember, he's that dragon, so I guess he's. Yeah, look, here's the word Draco over here. He's got a lot of serpentine stars, but this is kind of up closer to his head. Now let's zoom in and look at our field of view. So in the middle of that field of view is NGC 4236. It's kind of amazing, isn't it? All those loose stars, they are a part of it. But is this a cluster that we're in? Because there are a lot of what's this? NGC 42. Oh, that's this object. So no, it's not a cluster. It's just a very starred part of the sky. Lots and lots of stars. So NGC 4236. Look at that. Isn't that cool? And it's been up there all along. It doesn't have a Messier number. And it's just been waiting. It was there all the time. It was there all the time. You guys are going to tell me not to give up my day job. Wayne's got to run. Enjoy these, Doug. It's a big universe, but we have much bigger God. Amen. You are so right, Wayne. Okay, so let's go ahead and zoom in on this baby again. Boy, that's beautiful. I think we're losing some of the star material when we zoom in that tight. I think it's throwing it all the way out here sometimes. And if you zoom in, you can actually see, look at this material starting to come off here. Look at that arm. You can see it. Look at that. See that arm there? The spiral arm. Isn't that beautiful? Let's save this. And then in our save exactly as seen, let's make sure that we get that arm. NGC 4236. NGC 4236 on 2021-04-16. Now let's go back over to our targeting software. Let's do a new observation of this. Say, amazing spiral infrastructure. And for our attachment, 4236 and GC 4236. And then for our object, add user image, NGC 4236. Amazing spiral material on 4/16/2021. That might be too much, something like that. Not a very bright picture, but you can see that structure in the middle of this. So I think it's probably realistic. It is a very faint object, but boy, we're picking it up, aren't we? It's fun. Okay, well, it is 1 o'clock. I feel obliged to quit on time, even if I didn't start on time. I'm going to keep working on this focus. I'm going to keep learning these objects. I still feel like that what we have here is the equivalent of traveling through an unexplored cave with a fellow spelunker. You know, that's what it feels like to me. I don't feel like I am the tour guide in a developed cave in which I'm kind of taking people on a tour of the night sky. That's not what I would call this at all. I'm on a common path with you. This is a common journey that we're on, and we're walking this together. And I want to thank you guys for walking it with us. And whether you're viewing this live at 1 a.m. in the morning Eastern Time, or in Robert's situation at 5 in the morning, is that right, Robert? 5 in the morning? Uh, or whether you're watching this after the fact as a recording, what I want to do is thank you for putting up with me because I am on a journey learning this stuff. And you, whether you know it or not, you end up coming on a journey with me because you're learning this stuff as I'm learning it, you know? Like, for instance, not knowing that plate solving took the cue from the zoomed status in SharpCap. I didn't even know that till tonight. So I want to thank you for being here with us on this journey. And I just look forward to the next one already. It's a lot of fun. And when you come out here with us to the Emerald Hills night sky, I gotta say, I kind of feel like it's it's kind of like we're exploring that night cave together, and that's honestly a lot of fun. Um, you guys are traipsing through the mud and the muck with me. I'm going to go out here by the scope, and in the red light, I'm going to wave goodbye. And I don't know if you can see me or not. I brought my phone out here just to see if by chance you can see a person if he stands out here. Um, and if so, oh, yeah, there you can see me with my phone. I guess so. Yeah, you can see me. So thanks a lot for being a part of this, for gathering with us, for looking up at the Emerald Hills night skies with us. Do remember what we learned that it's all up there and it's constant, and there's something comforting about that it stays up there, and we will see you next clear sky over Emerald Hill skies, and we'll look forward to being able to catch up with you again at that time. Robert, good luck with your night patrol there with your service center. 6 a.m. My goodness, you've stayed up all night long, so it's 5 hours. Good luck with your traffic control there. Make sure you take good care of that royalty. All right, we'll say good night and God bless, and thank you, Lord, for making these beautiful objects for us to see.